In section 9.1, it's estimating a population proportion. We had our confidence intervals. And if it was a confidence interval about a proportion, we used one proposition. And again, that was 9.1. In 9.2, we were estimating population mean. So if we're estimating a population mean, remember we used t-interval. And I should show you where the slides are. Okay, 9.1, how to use that was located right here. So these are the instructions for 9.1. For 9.2, our population mean, the slide that told you how to use that on the calculator was this one right here. So if you need to refresh your memory on how to use a t-interval, you come back here and use that. We also had standard deviation. And we had variance. Now, standard deviation, the formula, I'm going to go double check this because I'm not sure if I actually remember this, but let's see, it was n minus 1 times s squared divided by the right chi-square, or yeah, right chi-square. Our upper bound was n minus 1 times s squared divided by our left chi-square. And lower bound here was n minus 1 times s squared divided by my right chi-square. And our upper bound was n minus 1 s squared divided by my left chi-square. Let's verify that. Is 9.3 is where those located at. Yeah, that's right. So 9.3. We also had, in this chapter, sample size. And we had our mean. This was this 9.2? That said n is equal to z alpha divided by 2s divided by e squared. And I'll verify these formulas just in case I don't remember. And then we had proportion or percentage. But then from there, we had two formulas. One where p hat's known. P hat is an amount from a previous study. And that was n is equal to p hat times 1 minus p hat times z alpha divided by 2 over e squared. And the other one is where p hat is not known. And that was n is equal to 0.25 times z alpha divided by 2 over e squared. Okay, let me verify that. Yeah, that's right. And yeah. Okay. 9.4 is a review section. And I'm not going to work problems out of it, but we are going to go through the different problems and identify what calculator function we should have used, or what calculator function we would use, and or what formula. And then also there'll be some sample size one we'll look at either in the review or the test. I forget which where it's at. We'll be ready for the chapter 9 test, which I'll be putting out there right after class. Again, same principle holds true. Don't wait till the last minute. There's a lot of outages now, it seems like, in some of these packages. So you'd be running a real risk if you wait until next Tuesday night to do it. Every one of the problems revolve around confidence intervals and sample size, because that's really all we did in this section or chapter. Okay, number 14. This is on some page. I'm looking right at it. Page 457 in the ebook. So number 13. See, blah, 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 blah. Construct and interpret a 95% confidence interval. Well, that tells us we're right here on this flow chart. So confidence interval for the mean. We're down here at the mean, and that tells us we would use t-interval. Your first reading should be just to kind of decide what we're working with. Or is it a confidence interval or is it a sample size problem? Number 14, blah, 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 blah. Construct a 95% confidence interval. So we're sitting right here. For the proportion, that would be 1 prop z end, 9.1. Number 15, blah, 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 construct a 90% confidence interval for the mean. Confidence interval for the mean, we would use t-interval, and that's section 9.2. Number 16, blah, 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 construct confidence interval for the mean. Confidence interval for the mean, we would use t-interval. Are these making sense so far? How you determine which technique to use? Now, if you've gone through the different sections and you know how to use those techniques, this section is just about how to identify which one to use. Okay. 17. Blah, 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 blah. Construct a 90% confidence interval for the proportion. Confidence interval for the proportion would be 1 prop z at 9.1. Number 18. Blah, blah, blah. Construct a 99% confidence interval for the mean. Confidence interval for the mean would be t interval. Number 19. E. Construct and interpret a 95% confidence interval for the mean. So confidence interval for the mean, that'd be t interval. Let's see, number 20. 20C, to be specific, construct a 90% confidence interval for the population proportion. Confidence interval proportion, 1 prop z at 9.1. 21. Says, estimate the proportion of individuals who suffer from sleep apnea who have gum disease with 95% confidence. And let's say refer to find how many, sample size, and so forth. Then you can assume it's confidence interval. So when it says estimate, it means find the confidence interval. So we want a 95% confidence interval, and it says proportion. That's 1 prop z at. Confidence interval proportion, 1 prop z at 9.1. Look at number 22. Estimate the standard deviation of a Clayton Kershaw fastball with 95% confidence. Again, they're not asking us to find a sample size. They're not asking how many should we sample, something along those lines. So they're asking for a confidence interval for the standard deviation. Confidence interval for standard deviation would be these formulas right here at 9.3. Boy, a lot of words. Confidence interval for the mean, that's a t interval. And let's see, chapter 9 review. Okay, 16, finally. Hypertension. In a random sample of 678 adult males, 20 to 34 years old, 20 to 34 years of age, it was determined that 58 of them have hypertension. A, ignore. B, construct a confidence interval for the proportion. That tells us 1 prop z at. Is confidence interval for the proportion. Now C, you wish to conduct your own study to determine the proportion of adult males 20 to 34 years old who have hypertension. What sample size? We're now sitting down here at the sample size down here. Specifically, they're asking us to study the proportion, which means I'm over on this side, on the proportion. Only question is whether p hat's given or not. So let's read a little closer now. Okay, what sample size would be needed for estimate to be within 3 percentage points with 95% confidence if you use the point estimate obtained in Part A? The point estimate is p hat. So that's what you'd find in Part A right here. So in this one, p hat's known, so I'd use this formula. Now B or D, you wish to conduct your own study to determine the proportion, again we're talking about proportion, of adult males 20 to 34 years old who have hypertension. What sample size? So we're at sample size. Specifically, we're at sample size proportion. Would be needed for the estimate to be within 3 percentage points to 95% confidence if you don't have a prior estimate. That means that p hat's not known. So p hat's not known would be this formula on the right side, 0.25 times z alpha divided by 2 re squared. Okay, let me find sample size for the mean. Case study. Well, I'll pick one out of 9.2. I'm not gonna have much luck. Looks like. Okay. Number 43. This is on page 447. Says. A recent Gallup poll asked Americans to disclose the number of books they read during the previous year. Initial survey results indicate that S is equal to 16.6 books. How many subjects are needed to estimate the number of books Americans read the previous year within 4 books with 95% confidence? So it's asking us how many subjects, so sample size. To estimate the number of books, well, it doesn't say mean, as far as I can see. It doesn't say average. But proportion is always like a yes or no question. It's not how many books you read. It would be, did you read a book last year? So it'd be a yes or no type question for proportion. So since they don't refer to a yes or no or 2 outcomes type case, I know it's not proportion, so by default it has to be mean. And since it's asking for how many subjects, we would be sitting here at the sample size mean, and we'd use this formula. Is there any questions on how to use that flow chart? Okay. I'm going to clear it off. In chapter 10, excuse me. Chapter 10, we get into hypothesis testing. We skip over 10.1. It's kind of a real generalized section about hypothesis testing. I don't really like because it's so general that it confuses students. So we're going to just dive right in. and we're looking at 10.2 hypothesis test for a population proportion. Now, when observed results are unlikely and the assumption of null hypothesis is true, we say result is statistically significant and we reject null hypothesis. We're going to talk a lot more about statistically significant here in a minute. We're not doing the classical approach. I'm skipping over that. Wait a minute, my idea. We are doing the classical approach. I'll wake up here eventually. Now here's the classical approach with the calculator. Write down a shortened version of the claim. Come up with a null and alternate hypothesis. H naught always has equals part on it. See if the claim matches H naught or H1. Draw the picture and split alpha into tails. We got our two tails, left tail and right tail, based upon the symbol that's in H1. Find your critical values, I and V norm. Test statistic using one prop Z test. And if test statistic falls in the tail, we reject H naught. If test statistic falls in the main body, we accept H naught. And then determine the claim based on step 3. Last time I taught this class, I just covered a p-value approach because I gave them the tests in the class instead of online. And online, I think you'll have a mixture of some items in there that'll ask you some of the components of the classical approach. Okay, we're going to look at problem number 1, and I'll explain each one of those different items. Okay. According to ABC News in June 2012, 36% of people believe in UFOs in the United States. If a sample of 200, that's sample size 200, find that 74 of them believe in UFOs, so X would be 74, whatever we're studying. Test claim that the percentage that believe in UFOs is greater now at alpha is equal to 0.05. And the claim is, test claim that the percentage that believe in UFOs is greater now. Well, it has to be greater than the value, and so it's greater than 36%. So greater than 0.36. We always want it in decimal form. So that's all the information the problem's given us. Okay, so back to here. Step 1, write down a shortened version of the claim. You'd like this just to be a few words. You don't want it to be real wordy. Don't put all the words that the book uses for the claim. Try to shorten it down to, if you can, three words. Greater than, if I think what symbol that represents, of course, is obviously the greater than symbol. Step 2, come up with a null and alternate hypothesis. H naught always has equals part. This H naught right here, that is our null hypothesis. This H1 is called the alternate. Alternate hypothesis. Now, the only symbols you can put on the alternate hypothesis are less than, greater than, or not equal to. The only symbol you can put on a null hypothesis is an equals. So when we're in, for this section, we're dealing with proportion, so this would be P for population proportion. So if we're wondering, where in the world do I put this greater than? What we said the symbol was up here. Well, the only place we can put it is on H1, because that's the only place you can put the greater than. So it'll be greater than 0.36. The only symbol you can put on null hypothesis is an equals. So it'll be equals 0.36. Now, the idea behind this is, and I should mention in the videos, if you watch them that I put out there, I also say you can put a less than or equal to here and a greater than or equal to here on H naught. That's not necessarily true anymore. It used to be, but they've changed the philosophy on that. So the idea currently is you can only put an equals on your null hypothesis. Now the idea behind this is the H1 or alternate hypothesis means something has changed. It's less than, it's greater than, less than, greater than, or not equal to. The null hypothesis means it's still the same as it was, so it's equals always. Usually the alternate hypothesis is the important one. That's one we're studying. You come up with a new drug for medicine, for cholesterol. You don't come up with a drug that increases your cholesterol level. Your goal is you want to come up with something that decreases it. It wouldn't actually make much sense for you to come up with a drug that keeps your cholesterol level the same as it is, because that's not usually why people take medicine like that. They take medicine to reduce their cholesterol level. Okay, so that's our null hypothesis or alternate hypothesis. Step 3, see if your claim matches H naught or H1. This is going to be based upon the symbol. Since this was a greater than symbol right up here, and this is a greater than symbol, then our claim is going to match H1. Again, you look at the symbols to match to see which one it goes with. Draw the picture and split alpha into the tails. For H1, we have a greater than on it. This says for H1, if we have a greater than on it, we're going to have a right tail. So this will be a right tail. And then it says split alpha into the tails. Now alpha is right here. Alpha is also called our level of significance. But I'm going to take the entire 5%, the 0.05, and put it into our tail, because we only have one tail. Now all of it adds up to 100%. So if I put 5% in my tail, I would put 95% in my main body. Now, we could take this 74 and divide by 200, and that would give us the proportion, the percentage, if we moved to 2 decimal places. When we're checking in our claim whether it's greater than 36%, that's not exactly what we're testing. We're not checking if it's greater than 36%, because our answer could be our answer with x divided by n could be 36.2%. If I compared 36% and 36.2%, they're about the same. So the question we're really asking with our claim is significantly, statistically significantly greater than 36%. You know, if you, as an example, if you had somebody that got a 2% raise, and you got a 2.0001% raise. Obviously, you got a raise greater than the other person, but is it significantly greater than? No. 2.0001% maybe means I got an extra 5 cents a week, maybe an extra 2 cents. I don't know. So that's not a significant increase. So again, when we're checking our claim here, we're checking for significance. And how that's controlled is with this alpha. So the alpha over here, if you have 5%, 10%, 1%, This helps control the results of our hypothesis test. Okay. Anyway, that's what alpha is. Now, step 5 says to find the critical values, and it says use INV norm. This right here is a critical value. Critical value is what separates the main body from our tail or tails. Now we're going to use INV norm on that. So for our critical value, we'll do INV norm. And remember, with INV norm, you want to pass in the area to the left. So here's my critical value. The area to the left will be 0.95. So, I'll do second vars and choose INV norm. And I'll pass in 0.95. And that gives us to 2 decimal places 1.64. Then we want to find something called the test statistic. Assuming I could actually get my way back there. There we go. Our test statistic we find using one prop z-test. So test statistic equals. So one prop z-test. Well, let's go look at it. So I press my stat button, right arrow twice over to my test, or left arrow once. We want one prop z-test, which on mine is number 5. So you can down arrow to it and press enter on it, or simply press 5. Now this top part here, P naught, this is asking us for the value off of our claim, off of H naught or H1, doesn't matter which one you pick, because they shall be the same. And I'll put in 0.36. Asks us for X, which is 74. Asks us for N, which is 200. Now this next line is asking for the symbol off of H1. The symbol on H1 is a greater than. So I want to right arrow until my flashing cursor is on a greater than symbol, and then I press enter. Again, that'll always match your symbol off of H1. And then down arrow to calculate and press enter. Now the test statistic here is z equals. Every section, every section will be different in that regard. Yeah, I shouldn't say that. 2 sections are the same. No, I'm lying. There's only one. They're all different. So z is equal to 0.29. How many decimal places? I would start off with 2. You might have to do more. What you're trying to figure out, you have to think of this line right here as a number line. So here's a number line. Here's 1.64. Number line wise, somewhere over here is 3, somewhere over here is 0, somewhere over here is -5, so forth. You're trying to figure out where 0.29 falls. Does it fall on the left side or the right side? Well, if this is 1.64 right here, 0.29, I don't know where it fall exactly, but it would definitely be over here on the left side. So step 7, if your test statistic falls on a tail, it doesn't. Our test statistic fell on the main body in this problem. If the test statistic falls in the main body, that says we accept H naught. So we accept H naught. Now, if we accept H naught, then that means we reject H1. You can think of H naught and H1 as opposites of each other. So if you accept one, you reject the other. If you reject one, you accept the other. Then it says determine a claim based on step 3. And step 3 says see if your claim matches H naught or H1. Now notice up here, we said our claim matched H1, which means whatever we say about H1 is what we're going to say about our claim. Since we rejected H1, that means we'll reject our claim. And in case you're wondering, well, what's your answer? Well, all of it's your answer. These are proofs, so you kind of verifying that the study's true or whatever you're looking at. Questions on that problem? Okay, clear that off. And look at our second example. Let's see. According to the Chicago Tribune, in 1990, 74% of teenagers believed in angels. If a sample of 500 teenagers, so N is 500, show that 410 believe in angels. So X is 410. Test a claim that percentage is the same at alpha is equal to 10%. So claim is, test a claim that the percentage is the same as, 74%. Is this referring to that? So same as 74%. And again, you want that in decimal form. Okay. Eventually. There we go. Step 1. Write down a shortened version of the claim. Well, we wrote it down as short as we could. Now, if I think what symbol that represents, same as means equals. Step 2, come up with a null and alternate hypothesis. H naught always has equals part on it. Remember, the only symbols we can put on H1 are less than, greater than, and not equal to. The only symbols we can put on H naught are equal. We're still dealing with population proportion, so these are still P. Our claim was an equals. And if I think, well, where do I put the equals? Well, you put it the only place you can put it. Equals goes right here. Now you think of these as opposites of each other. So if this is equals, this would be not equal. Let's see. Step 3. See if the claim matches H naught or H1. And it's based upon your symbol. Here we got an equals, here we got an equals. So our claim in this problem matches H naught. Step 4, draw the picture, split alpha into the tails. The symbol off of H1 for our problem is a not equal. So the symbol not equal says we're going to have two tails. And that means we're going to have two critical values, because critical values separate the main body from the tails. And then it says, draw the picture and split alpha into the tails. Our alpha in this problem is 10%. We got two tails, so we want to split that into the tails, which means we'll put 5% in each tail. Now, if we just put 10% in our tails, that means 90% goes in our main body. Like that. Now, we need to find our critical value. That's step 5, and it tells us to use INV norm. So for our first one here, we're going to use INV norm. Second vars, INV norm. It's always the area to the left. If I look at this one, this first critical value, the area to the left is 0.05. So I put in 0.05, and that gives us negative 1.64. The only time you'd have to take it to more decimal places is if your test statistic came out exactly the same as this, and you couldn't decide which side it fell on. So you'd have taken more decimal places. Let's find this one now. It's one on the right. Now we're going to use INV norm again. So second vars, and choose INV norm. Now here we have to add up all the area to the left. So I'm going to add up 0.05 plus 0.90 gives us 0.95. And then I press enter, and we get a positive 1.64. At least for this section here, not for the other sections of this chapter, but at least for this section, if you got two tails, if you got a negative 1.64, you'll have a positive 1.64. If you have a negative 1.96, you have a positive 1.96, and so on. Again, that just really applies in this section. Now we want to find our test statistic. And it tells us to use, in step 6, find the test statistic, we want to use 1-prop z-test. Okay, so go to stat, go to test, go to number 5. Oops. 1-prop z-test. P naught is a number off of our claim, off of H naught. H1 should be the same number in all three of those. So 0.74. X is 410. N is 500. The symbol off of H1 is a not equal to. So I want to put my flashing cursor on not equal and press enter. And I'll go down to calculate and press enter. Now the z equals is your test statistic. So my z equals 4.07, 4.08, rounded 2 decimal places, would be our test statistic. Now again, this is the number line. Here's negative 1.64, here's positive 1.64. Here's the left tail, the right tail, and the main body. We had to figure out where 4.08 would fall in terms of my number line. Well, it's greater than 1.64, so it'd fall somewhere over here. Don't know where, but it'd be over there. It says if your test statistic falls in a tail, which ours does, it fell in the right tail. What's that say we do? Reject H naught. So reject H naught. Now H naught and H1 you can think of as opposites each other. So if I reject H naught, that means I'm going to accept H1. And then we have to see which one our claim is matching. Notice in this problem, our claim is matching H naught. So whatever we say about H naught is what we say about our claim. Since we rejected H naught, that means we'll reject our claim. Questions on that problem? Let's look at one more using the classical approach, and then we'll go to the p-value approach. let's look at number 3. Let's see. According to the Chicago Tribune, in 1990, 50% of teenagers believed in ESP. If a sample of 400 teenagers, so that sounds like our sample size, n is equal to 400. Teenagers show that 190 believe in ESP. So X is 190. Test the claim that percentage is different nowadays that alpha is equal to 0.01. And it sounds like our claim was that it's different than, and it's different nowadays. They're talking about different than is 50% of teenagers have believed. So different than 50%. And I'll put that into decimal form like that. And that's all our information. So if I come back up here, step 1, write down a shortened version of the claim. Well, it doesn't get any shorter than that. One thing I will mention or mark down is what the symbol is. Different than means not equal. Different than means it could be less than, could be greater than. It's just not the same as. It's different. Step 2, come up with a null and alternate hypothesis. H naught always has equals part on it. Again, for H1, the only symbols you can put on it are less than, greater than, or not equal to. The only symbol you can put on H naught is an equal. P for population proportion. We said that our claim, the symbol was a not equal to. Well, the only place I can put a not equal to is on H1. So not equal to 50%. Again, you think of these as opposites each other. This is not equal to, the opposite of that would be equal. Step 3, see if your claim matches H naught or H1. And it's based upon the symbol. Since this is a not equal and this is a not equal, our claim matches H1. Step 4, draw the picture. Not equal to on H1 says we're going to have 2 tails. So we got 2 tails. Specifically, each one of those is a critical value. Step 4, draw the picture and split alpha into the tails. Now our alpha here is 0.01. So if we took 0.01, and we got 2 tails, you took 0.01 divided by 2 in your calculator, you get 0.005. So we take that 0.01, we're splitting it among our 2 tails. We're putting 0.005 in each tail. Now 0.01 is 1%. If I got 1% in the tails, that must mean I have 99% in my main body. Step 5, find the critical values, I and V norm. For our left critical value, second vars, I and V norm. For this one on the left side, we want to put in the area to the left of it, which is 0.005. And that gives us negative 2.58. I know the other ones will be a positive 2.58 based upon what I said, but I'm going to go ahead and go through the steps. Second vars, choose I and V norm. Now for the one on the right, we want to add up all the area to the left. So we're going to add up 0.005 plus 0.99, which gives us 0.995, which gives us a positive 2.58. Now we need to find a test statistic For the test statistic, it tells us to use one prop z-test. So go to stat, test, one prop z-test is number 5. The number off of your claim, H0 or H1, 0.5 or 0.50, it gets rid of the 0 if you put it in. X is 190. N is 400. N's always your larger number, so you can't mess that up really. And then the symbol off of H1 is a not equal to again. So if you're not equals is not highlighted, then put your flashing cursor on it using your arrow keys and press your enter. And then we'll go down to calculate. And Z is our test statistic, which is equal to -1 in this problem. Okay, now that's the number line. This is -2.58. This is positive 2.58. Over here, remember, is like -3. Over here is a positive 3. In the middle here is any value between -2.58 and positive 2.58. -1 will fall in the main body here because -1 is actually greater than -2.58. Okay, so if your test statistic falls in the main body, this says accept H0. If we accept H0, that means we'll reject H1 because we treat them as opposites to each other. And since our claim matches H1, whatever we say about H1 is what we say about our claim. We rejected H1, so we'll reject our claim. Now, one last thing I'd like to mention here about the accept. I want to do some problems and us to understand the accept and reject before I muddied the water. You will not find the words accept in most stats books. They'll use the wording do not reject. Let me give you an example. A woman marries a rich man. They go off on their honeymoon. First night on their honeymoon, they're down eating dinner, and he chokes and dies. Police investigators, no foul play, so forth. She collects a huge chunk of money, millions, life insurance. 6 months later, she marries another man who's wealthy. He is going down to the store on the first day of their honeymoon. His brakes fail, and he goes flying off a cliff. Police investigate it. It's a failure. Maybe it's a recall or whatever. Nobody's to blame, so forth. She collects the life insurance. 6 months later, she marries another rich guy, and they go on a honeymoon. They're out skiing on the first day of their honeymoon. He skis off the side of the cliff. She's nowhere close to him, and so forth. Police investigate it. They don't find anything wrongdoing. She collects the insurance money. I could go on and on, but what's she doing? Well, she's killing her husband. Killed her husband for the life insurance. Do we have any proof of it? No, we don't. So we don't accept her innocence. Accept is a really strong word. Instead, what we say is we do not reject her innocence. Maybe she's just a very unlucky person. And maybe it's a real coincidence that it always happens on the first day of their honeymoon, not before, not after, always the first day. In statistics, accept is a very strong word. They don't like to use that. Now, if you reject something, that's pretty clear. You can reject something because you found like one thing wrong. But to accept it is saying with all my heart, 100% I believe it. And they don't use that. So they use the word do not reject. Now I'm going to stick with accept and reject because students click better with it. But if you want to put do not reject instead of accept, you're welcome to do that. Okay. We're going back to problem number 1. And we're going to work it again. this time using the p-value approach. Okay, so I'm going to write down everything I had before. Tell us the sample of 200 people, so n is 200. They're telling us that of those 274 of them believe in UFOs, so x is 74. Alpha, this Greek letter, is 0.05. And our claim was UFOs is greater now, so greater than 36%. Okay, so our p-value approach is right here. Step 1, write down a shortened version of the claim. Well, we already got that. This is pretty short. And the symbol, again, that goes along with that is a greater than. Step 2, come up with a null and alternate hypothesis. H naught always has equals part on it. That's the same as before. Now this is a greater than, and where I'll put the greater than is on H1. That's the only place you can put greater thans. And just like before, we said this has to be in equals, it still has to be in equals. That doesn't change. Step 3, see if your claim matches H naught or H1. Since this is a greater than and this is a greater than, our claim matches H1. It's always based upon your symbol. Now, instead of doing those other steps, find a critical value, find a test statistic, we're going to find p-value using one prop z-test. People usually like this method easier, or usually like it better because it's easier. So let's go to one prop z-test again. Go to stat, go to test, one prop z-test number 5. The number off of our claim, H naught or H1, is 0.36. X is 74. N is 200. The symbol off of our H1 is a greater than, so I want to right arrow over twice to the greater than and press enter on it. So all of that's still exactly the same as when we did it before. Now if I go down to calculate, the test statistic was the z equals, which we saw. The value right below it, p equals, that's our p-value. P-value deals with a probability. So I'm going to write it down. P is equal to 0.3841. After we work a couple of examples, I'll go talk about P a little bit more, but we'll come up with that. Well, what we do with that then is on step 5, we compare it to alpha. If p-value is less than alpha, we reject H naught. If p-value is greater than alpha, we accept H naught, and then we determine the claim based on step 3. Well, obviously, P is greater than alpha. P is 0.3841, alpha is 0.05. So this is about 38%, this is about 5%. This says if p-value is greater than alpha, it says we accept H naught. So we accept H naught. Remember, H naught and H1 are opposites to each other, so if I accept H naught, that means I reject H1. And since our claim matches H1, whatever we say about H1 is what we're going to say about our claim. So we'll reject our claim. And all that would be your answer. Usually people like this because technology usually gives you the p-value direct. You plug in a few parameters, it gives you the p-value, and all you have to do is do a simple comparison to alpha to see if it's greater than alpha or less than alpha. And based upon that, then you just write down your conclusion. Questions on that problem? Okay, let's look at one more of those. Maybe I'll pick one out of the book. Okay. I'm gonna look at number 18, Nexium. Okay. Nexium is a drug that can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. Now, reduce kind of implies less than, but let's read on. Manufacturer of Nexium claims that more than, I was wrong, more than 94%. So claim is more than 94%. And again, I want that in decimal form. Nexium claims that more than 94% of patients taking Nexium are healed within 8 weeks. In clinical trials, 213 of 224. So N is 224. N will always be the larger value. And 213 is my X. 213 of 224 patients suffering from acid reflux disease were healed after 8 weeks. Test and manufacturers claim that alpha is equal to 0.01. Okay, so using the p-value approach, step one, write down a shortened version of the claim. Yeah, we did that. But we have to think what the symbol that is. More than means greater than. Step two, come up with a null and alternate hypothesis. H naught always has equals part on it. Again, the only symbol you can put on H1 is less than, greater than, or not equal to. Only symbol you can put on H naught is an equals. Since this is a greater than, where it has to go is on H1, because that's the only place I can put a greater than. And no matter what, this is always equals on H naught. Step three, see if your claim matches H naught or H1. It's based upon your symbol, greater than, the claim matches H1. And then step four, find your p-value using one prop z test. So if I go to one prop z test, stat test number 5, the number off of claim H naught or H1 is 0.94. X is 213. N is 224. The symbol off of H1 is a greater than. Mine's our greater than's already selected, but if it wasn't, I would right arrow over to it, press enter on it to select it, and I choose calculate. Now the P equals is our p-value, which is 0.2462. Now again, we're comparing that to alpha, and you can see that P is greater than alpha. So for this, if p-value is greater than alpha, it says we accept H naught. So we accept H naught. If I accept H naught, that means I reject H1. And since our claim matches H1, whatever we say about H1 is what we say about our claim. We rejected H1, so that means we'll reject our claim. And again, the entire thing there is your answer. It's not just accept or reject the claim. It's the entire piece because you're trying to verify the study. Okay. This p-value, I don't have a slide on it, but let me just talk about it. Why people like this even better is because it gives them a level of significance. If it's really close to 0.01, like if I had come up with 0.011, just a little bit greater than alpha, then that means this study could have went either way. I would still say the same conclusion because this is greater than, but in reality, you can't. It's probably meaningless. It could have one data result one way or the other would have flipped it. Since this is pretty extreme, it's pretty far away from this, then we're pretty sure of our results. So that's what the p-value gives you, and that's what people like. Now, sometimes a calculator will give you things like this. It'll tell you p is equal to 2.43 e negative 0.05. Now, the p-value is a proportion, so it gives you a value between 0 and 1. You cannot have a p-value greater than 1. When you see this, that e negative 0.05, how you interpret that is that tells you to move your decimal point 5 places to the left. So this would be 0.0000243. And that would be your p-value. So keep that in mind when you're using a calculator and you end up with that e negative 0.05, that usually means it's a very small p-value, or e negative 6, or whatever it is. So, questions on any of that? Well, I'll put out the chapter 9 test. I'll put out the two sections we finished, 9.4 and 10.2, for the drop boxes for the homework. And then next time we'll continue on in chapter 10. But have a good day, and I'll talk to you later.